Hey guys, Raz here. Today we'll be looking at the division algorithm for AS and A-level maths, and then also the fact theorem, remainder theorem. I'll try and tie them all up in this one video. So I've got a few example questions here that we're going to use in a moment. Before we do that, I'm just going to remind us how to do division. So if we do short division versus long division, and we can just see what the different techniques are. So if I gave you this, most people would use short division to solve it. We'd have 13 doesn't go into 4, but it goes into 41 3 times. 3 times 13 is 39, which means there's a remainder of 2. 13 goes into 29 twice, remainder of 3, and 13 goes into 39 exactly 3 times. Job done. Long division is just how we write out what we're doing. So with long division, same question, but 13 goes into 41 3 times, and then we generate the remainder by doing what 3 times 13 is and writing it out. So when we subtract there, we get 2. And the next question we have to ask ourselves is how many 13s go into 29 like we did here? Again, the answer was 2. And then we think, well, 2 times 13 is 26, which leaves 3 left over. Therefore, how many 13s go into 39? 3. 3 times 39 is 39. Therefore, that goes in exactly. Yeah, there was no remainder there. So it's this method on the right that we're going to advance with the A level. So let's have a look at this first question. So we're going to write our bus stop out. X plus 3 into x cubed plus 2x squared minus 2x plus 3. So as before, we ask ourselves, well, what times x? How many x is going to x cubed? Well, x squared times x is x cubed, so the answer is x squared. Now we generate the remainder by multiplying x squared with everything else. So everything else being what's in that bracket there. So x squared times x is x cubed, and x squared times 3 is 3x squared. And now by subtracting, we get our remainder. How many x's go into negative x squared? Well, x times minus x will be negative x squared. So we get that bit there, and then we multiply again to generate the remainder. So minus x times x is minus x squared. Minus x times 3 is minus 3x. Now those negative x squareds will cancel. But minus 2x minus minus 3x is plus x. Well, what do I times x by to get x? 1. And 1 times x plus 3 is x plus 3. Therefore, 0 remainder. Yeah, I ran out of space there, but you can see x plus 3 take away x plus 3, 0. So, make a note of that, and then try this. Then I'd advise you to pause the video and try this question. Welcome back. So let's give this one a go. X minus 4 into 3x cubed minus 13x squared plus 2x plus 8. So we have to multiply x by 3x squared to get 3x cubed. Now we multiply 3x squared by x minus 4, get 3x cubed minus 12x squared. Subtract that. Minus 13 minus minus 12 is minus 1. Okay, well, x times minus 1x is negative x squared. Now we multiply that negative x by x and minus 4. Minus x times minus 4 is plus 4x. 2x take away 4x is minus 2x. Drop that 8 down. What do I times x by to get negative 2x? Minus 2. Multiply the minus 2 by the x and the minus 4. Job done. Yes, that was example 2. Now, let's try this third one. This time we have a remainder. So I'm going to give that one a go. It's exactly the same thing. Now, what will happen is we should get a remainder instead of getting 0 when we subtract at the very end. So x times 2x squared gives me 2x cubed. Now multiply the 2x squared by the x and the 1. That gives me 2x cubed plus 2x squared. Next step, subtract. 2x cubes cancel. 3x squared minus 2x squared is x squared. Drop that down. What do I times x by to get x squared? 1x. And the x multiplied by x and x plus 1 gives me x squared plus 1x. Subtract. I get x. Drop that down. Minus 1. Now, x times what is x? And now when I multiply x by 1 and 1 by 1, I get x plus 1. So the x's cancel when we subtract, but this time minus 1 is minus 2. So we get a remainder of minus 2. Which means 2x cubed plus 3x squared plus 2x minus 1 divided by x plus 1 equals 2x squared plus x plus 1 minus 2 over x plus 1. And that's what the remainder means, yeah? So this links us to something we're going to call the factor theorem and the remainder theorem. So the factor theorem tells us if x minus a is a factor, then f of a will equal 0. Well, what that means is if these are indeed factors, if I sub in negative 3 into this, I'll get 0. If I sub in positive 3 into this, I'll get 0. And that will prove it's a factor. Yeah, so let's do that one by one. So the first one, we have negative 3 cubed plus 2 times negative 3 squared minus 2 times negative 3 plus 3. Well, negative 3 squared is negative 27. Minus 3 squared is 9 times 2 is 18. Minus 2 times minus 3 is plus 6 plus 3. Well, that equals 27. Factor theorem worked. Let's try out the second one. This time we're subbing 4 in. So 3 times 4 cubed minus 13 times 4 squared plus 2 times 4 plus 8. And if that equals 0, then x minus 4 is a factor. Well, 4 cubed is 64. 64 times 3 is 192. Minus 13 times 16. What will that be? $208 plus 8 plus 8. So if we add 8 onto there, we get 200. Yeah? Um, 13 times 4 squared, 13 times 16. Oh, yeah, that's meant to be 208. So we have 208 minus 208, which equals 0. And let me be clear there. I think I said 13 times 16 is 208, but I wrote down 204. So we get 0 again. Now, the remainder theorem is very similar, but if we do the same result, this time we won't get 0. We'll get what the remainder is. Yeah? So we did the second one, and we ended up with a remainder of -2. So if I sub in -1, then that remainder should be -2. If we rely on the work we did earlier. So 2 times -1 cubed plus 3 times -1 squared plus 2 times -1 minus 1. So that gives us -1 cubed is -1 plus 3 -2 minus 1. We can see that equals 0. So that is the same answer we got as when we divided. So that is the remainder theorem. It's very similar to the factor theorem. It's just the result. So the remainder theorem states remainder theorem if if x minus a is a divisor, then f of a will equal r. Yeah? So let's do a little bit more division. Okay, let's try this one. So I like this one because we can see we've got a few bits missing. So we have 2x plus 1 into 4x to the 4 minus 17x squared plus 4. But to do this, what we must do is write out the missing powers. So everything is there. So we have a 4x to the 4. We have 0x cubed. We have 17x squared, but we have 0x's. And we have a plus 4. If we do not do that, it won't work. Yeah, if we don't do that, the question won't work. And that's all I really wanted to show you here. So let's just do it. So 2x, we need to times by 2x cubed to get 4x to the 4. So 2x times 2x cubed is 4x to the 4 plus 2 times x cubed. You can see straight away we needed that 0x cubed, didn't we? 0 minus 2 is -2. I need to multiply 2x by minus x squared to get minus 2x cubed. And then multiply that. The minus 2x cubes cancel. Minus 17 minus -1 is -16. The 0x drops. I need to times 2x by -8 to get negative 16x squared. That gives me negative 16x squared minus, sorry, I need an x there. That gives me negative 16x squared minus 8x. Now, 0 minus 8x is plus 8x. Drop that 4 down. What do I times 2x by to get 8x? Exactly, we get 4. And we multiply that out, we can see we've got 0 remainder. So I hope that video has been useful. It's explained in brief the the factor theorem and remainder theorem, and we've looked at the division algorithm and little tricks of the trade to answer, most questions on that topic. So I've been Raz. See you again soon.